The strangest snowball we have ever seen may be older than the sun that is melting it. Most people did not expect the next visitor from deep space to arrive as a dirty comet carrying clues from before Earth even existed. Stay with me, because this story begins as a faint speck and ends by making our own solar system look a little less normal. And before we go farther, subscribe if you want the next cosmic surprise to land in your feed before it disappears behind the sun. At first glance, 3I/Atlas did not look like a revolution. It looked small, dim, and easy to file away as one more object in a sky already packed with them. But some discoveries do not shout when they arrive. They whisper, and the whisper changes the room. This comet did not come from around our sun. It came from somewhere else, somewhere so far away and so long ago that even saying it out loud feels unreal. It crossed into our neighborhood, warmed up, and gave off a cloud of gas like breath on a winter morning. That cloud became a message, and James Webb knew how to read it. To understand this, we first need to go back a long way. A lot of people hear interstellar object and picture a silent rock with nothing much to say. That is the first thing to correct. 3I/Atlas is not interesting because it passed by us. It is interesting because it is active, icy, and leaky, which means it turned itself inside out just enough for us to inspect what it is made of. That matters because dead rocks hide their past. Comets do the opposite. When sunlight hits them, their ice turns straight into gas, a process called sublimation, which is just a fancy way of saying frozen stuff skips the liquid step and steams off. It is like opening a freezer and seeing cold air spill out, except this freezer may have been drifting between stars for billions of years. And early on, 3I/Atlas was easy to underestimate. It was only the third known interstellar object ever found. The first, Oumuamua, sparked endless arguments. The second, Borisov, was a comet, but we caught it under different conditions. A third visitor could have felt like a sequel, and sequels often seem less exciting than the original shock. But underdogs are dangerous that way. People assume the third one cannot change the story as much as the first one. Then the third one walks in carrying the key detail everyone had missed. That is almost exactly what happened here. The object was first reported on July 1, 2025, by the NASA-funded Atlas Survey Telescope in Rio Hurtado, Chile. ATLAS stands for Asteroid Terrestrial Impact Last Alert System, which sounds like something built to stop disaster movies from becoming real life. Its job is to keep scanning the sky for fast-moving trouble. Instead, on that day, it found a visitor from another star system. When astronomers checked its path, they saw something important. They expected an orbit that loops around the sun, like a train following the same track again and again. What they actually found was a hyperbolic path, which means the curve was open, not closed, and the object was moving too fast to belong here. Think of a skateboarder rolling through your driveway without ever turning into the garage. At discovery, NASA says it was about 410 million miles from the Sun, that is 670 million kilometers, already inside the orbit of Jupiter. It was moving about 137,000 miles per hour, or 221,000 kilometers per hour. That is not just fast, that is faster than a rifle bullet by a ridiculous margin, more like crossing the United States in a few minutes. Scientists expected that if the object came from elsewhere, they might struggle to learn much before it moved on. What they actually found was a comet with an icy nucleus and a bright coma, a cloud of gas and dust around it. That coma was the gift. It was like a sealed jar cracking open just enough for the smell of the kitchen inside to escape. And that kitchen mattered, because chemistry is memory. A comet does not write a diary. It carries ratios, ingredients, frozen leftovers from the place where it formed. If you can read those ingredients, you can work backward to the kind of system that baked them. As 3I/Atlas moved deeper into the solar system, the Sun turned up the heat. Its closest pass to the Sun, called perihelion, came on October 30th, 2025. NASA says it passed at about 130 million miles, or 210 million kilometers, from the Sun, just outside the orbit of Mars. By then, it had sped up to about 153,000 miles per hour, or 246,000 kilometers per hour. That sounds huge, and it is, but I want you to hold two scales in your head at once. On one scale, this is a traveler crossing the black gulf between stars. On the other, its power to teach us depends on tiny changes in light, the kind of delicate signal weaker than the little lamp inside a refrigerator. By December 2025, the timing became almost perfect. The comet had rounded the Sun and was moving away, freshly warmed. Its ancient ice was turning into a brighter gas cloud, making its hidden chemistry easier to measure. This was the moment teams had been waiting for. NASA, ESA, and the Canadian Space Agency had a tool for exactly this kind of moment. The James Webb Space Telescope is famous for looking at early galaxies, but here it acted like a chemical detective. Instead of taking a pretty snapshot and stopping there, Webb broke the comet's light apart. It turned glow into evidence. The first surprise was not even what Webb found. The first surprise was that scientists were allowed to interrupt Webb's planned schedule to look at this thing. That tells you how rare the chance was. When the most powerful telescope in space changes its calendar, it is like stopping a hospital operating room because a stranger just walked in with a one-of-a-kind clue. Martin Cordner of NASA's Goddard Space Flight Center led one of the key studies. His team used NIRSpec, the near-infrared spectrograph, on Webb. NIRSpec is a tool that spreads infrared light into a fingerprint so scientists can tell which molecules are present. If ordinary light is a melody, NIRSpec helps separate the instruments. What did researchers expect from that fingerprint? They expected something that might resemble comets from our own solar system, maybe unusual but not deeply alien. What they actually found was chemistry that did not match the familiar pattern. And the difference was not small, like swapping one spice in soup. It was like tasting a cake and realizing the sugar came from another world. Here is where the story begins to shift from strange to serious. On June 22, 2026, results from that NIRSpec work were published in Nature. That matters because Nature is one of the journals scientists use when the evidence has gone through intense checking. This was not a rumor. It was a measured result with numbers attached. The first major finding changed everything. Scientists expected the amount of deuterium in the comet's water to land somewhere near what we see in solar system comets. What Webb actually found was deuterium, or heavy hydrogen, at about 30 times the level seen in our own comet population. That is not a nudge. That is like opening a pantry jar and finding marbles where you expected rice. Let me slow that down. Hydrogen is the simplest atom, the basic little building block in water. Deuterium is a heavier version of hydrogen. So heavy water is still water, but with a slightly heavier ingredient mixed in, and those ratios can tell you what temperatures and conditions existed when the ice first formed. If a comet carries a lot of heavy water, it suggests deep cold. Not just a cool night kind of cold, a buried in shadow, never thawed, ancient cloud kind of cold. The kind of cold where chemistry can stay almost untouched, like food locked in a freezer no one has opened for ages. So what did scientists expect? They expected a record shaped by a system more like ours. What did they actually find? They found signs that 3I/Atlas likely formed in a much colder environment and much earlier in the history of the Milky Way. In plain words, this comet may be carrying winter from a galaxy that was still young. What do you think matters more here? The comet's age or its chemistry? And could you drop that in the comments so I know which trail to follow next? Cordner said this was a unique chance to study an ancient object that probably predated our sun and solar system. That phrase matters. Predated our sun. Our star is about 4.5 billion years old. This comet may be much older. Webb's measurements suggested something even wilder. The team estimated that 3I/Atlas could have formed as long as 10 to 12 billion years ago. That points back toward a period astronomers sometimes call cosmic noon, when star formation across the universe was roaring. Imagine the busiest bakery in town at lunch hour, except the bakery is the galaxy, and the ovens are stars turning on everywhere. Now pause on that number. 10 to 12 billion years. That is more than twice the age of Earth. It means this small, dirty object may have started forming when our sun, our planet, our oceans, and every dinosaur still belonged to the future. The second major finding was just as strange. Scientists expected that if a very volatile gas like methane were present, it might have escaped early or been hard to catch. What Webb actually detected, using its MIRI instrument, was methane gas directly coming from the comet after perihelion. Like finding the smell of fresh paint hidden inside a house you thought had aired out long ago. That result came from another Webb study published on June 1, 2026, in the Astrophysical journal Letters. This time the tool was MIRI, the mid-infrared instrument. MIRI looked on two separate dates, December 15th to 16th, 2025, and then December 27th, 2025. By then, the comet was already heading back out, 205 million miles from the Sun at first, then 236 million miles. Those dates matter for another reason. Webb was not catching the comet at one frozen instant. It was watching change happen over days, the way you might check a candle once, then again, and notice how much wax has vanished. That let scientists compare not just ingredients, but behavior. Scientists expected the outer layers to tell most of the story. What they actually found suggested something hidden deeper down. Methane is so easy to vaporize that its delayed appearance hints it was buried below the surface and only released after the sun's heat reached deeper icy layers. That is like leaving a frozen dinner on the counter and only later realizing the center is still full of trapped steam. Webb also confirms something else. Scientists expected some carbon dioxide because comets often carry it. What they actually found was that 3I/Atlas stayed unusually rich in carbon dioxide compared with water, even against the background of typical solar system comets. It was less like a standard recipe and more like a drink mixed with far too much of one ingredient. Webb also saw gas production drop sharply as the comet moved farther from the sun. Scientists expected some fading, because less sunlight means less heating. What they actually found was that water dropped most strongly, while the easier-to-vaporize gases could linger longer. Think of wet clothes drying in layers, with the thin outside moisture leaving before the dampness buried deeper in the fabric. There is a lesson hidden in that behavior. A comet is not a glass marble that changes all at once. It is more like a layered freezer meal, with some ingredients near the top and others buried lower, waking up at different times as heat sinks inward. That is why methane showing up later was such a clue. And notice the pattern. Expected one thing, found another. Then came the compression, the simple picture that makes the surprise stick. That is how science really feels in the room, not like a clean answer, but like opening cupboard after cupboard and seeing labels you did not expect. The third discovery puzzled scientists in a quieter way. They expected the carbon isotope mix to look more familiar because later generations of stars enriched the galaxy with more carbon-13 over time. What Webb actually saw were only traces of carbon-13 compared with lighter carbon-12. That is like checking the rings of a tree and finding fewer than your neighborhood usually grows. Why does that matter? Because isotope ratios are clocks with no ticking sound. They do not tell time in seconds. They tell time in environments, in long cycles of star birth and star death. And this particular clock pointed backward. If 3I/Atlas is low in carbon-13 and high in deuterium, the simplest picture is not that it formed near a warm young star like ours. The simplest picture is that it formed in a cold, dense region around a much earlier system and then got thrown out. Not nudged out, thrown out. Like a seed kicked from a storm drain and left to travel street after street for ages. By this point, the underdog part of the story comes into focus. This was supposed to be just the third interstellar object, not the first, not the one people had already turned into a cultural event, but the third one may be the one that gives us the clearest chemical reading yet. Sometimes the quiet kid in the back of the class is the one holding the answer sheet. There is another reason this matters. For years, when scientists talked about the chemistry that may lead toward life, they had only one confirmed place where the whole chain clearly worked. Here. Here means our solar system. Here means Earth. Stephanie Milam of NASA Goddard put it plainly in the NASA release. She said the bigger picture is the possibility of prebiotic chemistry elsewhere in the galaxy. Prebiotic just means the chemical ingredients that can come before life. Not life itself, but the pantry items life may need. If this kind of space detective work makes the universe feel real to you, would you like the video and tell me why that matters, so the algorithm learns these careful stories are worth showing to more curious people? And that is where the story gets emotionally bigger than one comet. Because 3I/Atlas is not only a thing, it is a sample. A sample from somewhere we did not build a spacecraft to reach. Think about what that means. We spend billions of dollars and decades of effort to send probes to planets, moons, and asteroids inside our own system. Here, the galaxy delivered a sample to us for free. Not to our doorstep exactly, but close enough for Hubble, Webb, and ground telescopes to inspect. It is cosmic mail, arriving battered but readable. There was also a practical race against time. In late October 2025, the comet passed behind the Sun from Earth's point of view, and ground-based tracking had to pause. NASA says observations resumed on October 31st. That gap is a reminder that even with giant observatories, nature still hides the page just when you are trying to finish the sentence. NASA's Hubble Space Telescope helped constrain the nucleus size. As of August 20, 2025, astronomers estimated the solid core was no smaller than 1,400 feet, or 440 meters, and no bigger than 3.5 miles or 5.6 kilometers. That is a range from about the length of a few city blocks to something that could swallow a small town. Huge in a parking lot, tiny in space. And it never threatened Earth. NASA says it came no closer than about 170 million miles, or 270 million kilometers, to our planet. That happened on December 19, 2025. So this was not a disaster story. It was a reading opportunity. Which is almost funny when you think about how human brains work. If a strange object might hit us, everyone looks up. If it only rewrites part of our origin story, fewer people notice. But the second kind of event may matter much more in the long run. The fourth finding was not a single molecule. It was the pattern formed when all the clues sat together on the table. Scientists expected a comet that could be unusual in one or two ways. What they actually found was a stack of oddities that pointed in the same direction. Very old, very cold, chemically distinct. Like hearing three different witnesses describe the same stranger in the same way. One witness was methane, another was carbon dioxide, another was heavy water and the deuterium inside it. Another was the low amount of carbon-13. Each clue alone is interesting. Together, they start to feel like a biography. That biography says 3I/Atlas may have spent millions or billions of years in interstellar space after being ejected from its home system. But its deeper story started earlier still. It likely formed in a dense, cold cloud, then around a young star in an era when the galaxy itself was younger. After that, something flung it out. What could do that? A giant planet shifting its orbit, a close pass with another star, a violent reshuffling of newborn worlds. Imagine kids running through a kitchen and knocking a spoon off the table, except the kids are planets and the spoon travels for 10 billion years. And here we reach the part scientists will tell you they do not fully understand yet. We do not know if 3I/Atlas is a weird exception or a fairly normal product of ancient planetary systems. The models had predicted some differences from local comets, yes, but this combination of isotope clues and volatile behavior pushes the picture into less settled ground. That is a precise kind of mystery, not a movie trailer mystery. In other words, this discovery answers one question and opens 5 more. Did most early star systems make icy bodies like this? How often were they thrown out into the dark? And if old comets can carry rich chemistry across the galaxy, how many building blocks of planets and maybe life have been wandering between stars all this time? A separate study helped widen that window. Cyrielle Opetom of the University of Edinburgh led work using the European Southern Observatory's Very Large Telescope. That team studied carbon and nitrogen forms in cyanide. Different tool, different chemical trail, same larger goal. Reconstruct the comet's home address from leftovers in the gas. And this matters because no single telescope owns the truth. One team sees one band of light, another sees another. When those views agree, confidence rises the way a picture sharpens when you twist a camera lens into focus. This is the part where science starts to feel like archaeology in reverse. An archaeologist digs down through dirt to reach older layers. Astronomers cannot dig into a comet from another star. So they wait for sunlight to warm it, then read the gases that leak out, like steam escaping from a pie tells you what fruit is inside. The more exact the numbers got, the more intimate the story became. Not just very fast, but 137,000 miles per hour on arrival and 153,000 at perihelion. Not just far away, but 170 million miles from Earth at closest approach. Not just old, but possibly 10 to 12 billion years old. That is what discovery sounds like when wonder gets measured with a ruler. And yet the ruler never kills the wonder. It sharpens it. Knowing the date was December 27, 2025, does not make the second Webb scan less magical. It makes it more real, like writing a birthday in a family Bible instead of saying, "a long time ago." There is also a quiet statistical shift happening here. With one interstellar object, every claim feels shaky. With 2, you can compare but still worry you are fooling yourself. With 3, especially one this rich in chemistry, you finally begin to test whether our local sample was too small all along. That is a big deal in science. Patterns do not become truth just because they are exciting. They become useful when the next example either fits the old picture or breaks it in a clear way. 3I/Atlas did not politely fit. It leaned on the wall and cracked the frame. When you picture all this, do you know someone who would love it too? And would you share this video with them so the story can reach people who are waiting for a reason to look up again? Now let us zoom back in. Picture the comet's coma as a dim, glowing shell around a darker core. Picture invisible gases spreading into black space. Picture Webb far away, cold and steady, collecting light that has brushed through that gas and splitting it into a rainbow our eyes cannot see. There is almost no sound in that picture, and still it feels noisy. Not noisy like traffic, noisy like information. A silent spill of molecules, each one carrying a tiny stamp from another system, another era, another temperature. This is why the phrase changes everything is not as exaggerated as it sounds. No, 3I/Atlas does not prove life exists elsewhere. No, it does not tell us the exact star it came from. But it does widen the range of what planetary systems may have been making long before our sun turned on. For a long time, our solar system sat in our minds like the standard model home. Maybe slightly special, maybe fairly average, but at least a reasonable template. Now a comet from outside arrives carrying chemistry that makes that assumption wobble. That wobble matters. Because if our local comets are not the universal default, then our local history may not be either. The kind of cloud our sun formed in, the balance of isotopes around it, the way ice and gas were stored and reworked here. All of that may represent just one style of cosmic upbringing. And when you change the sample size from 1 to 2 to 3, the human mind starts behaving differently. One example is an anecdote. 2 examples are a pattern you argue about. 3 examples begin to pressure your worldview, especially when the third comes with sharper chemistry than the earlier cases. Oumuamua made people ask whether we were ready for interstellar visitors at all. Borisov showed that an interstellar comet could look in some ways comfortingly comet-like. 3I/Atlas now tells us comfort has limits. A thing can look familiar at a glance and still come from a radically different, deep history. That idea reaches beyond comets. It reaches toward planet formation. It reaches toward how often young systems throw material away. And it reaches toward the oldest question of all. When the ingredients for life gather, do they gather in many kitchens, or was ours a rare recipe? If this discovery makes our own solar system feel more precious or more strange, would you leave a comment saying which one you feel, so I can tell where your mind landed after this story? There is something deeply human in how this knowledge arrives. Not through a hero standing on a comet, not through a sample return capsule falling into a desert, but through patient instruments, careful math, and teams spread across institutions like NASA Goddard, STSCI, ESA, and universities that keep checking one another's work. That matters because trust in science is built the slow way. A telescope observes, another team compares, a journal reviews, a different observatory adds a piece. It is less like lightning and more like stitching. And the stitching is beautiful here. NIRSpec mapped molecular fingerprints. MIRI captured a mid-infrared chemical view. Hubble helped pin down the size. The Very Large Telescope extended the chemical story from the ground. You could call that overkill for one comet. But this is not really one comet. It is one chance, a brief crossing through our system by an object that may have spent most of existence in the dark between stars. Miss that chance, and it is gone forever. By spring 2026, it was fading from easy view. The visitor kept going. It did not care whether we understood it. That is another beautiful thing about nature. The universe does not hold still for us. It passes by, and we either notice or we do not. James Webb noticed, and because Webb noticed, we now have reason to think some ancient planetary systems built icy bodies under conditions very different from our own. Not warmer, colder, not later, earlier. That simple pair of flips changes the frame. If earlier systems were making frozen bodies with this kind of chemistry, then the story of planet making in the galaxy may be wider
messier, and older than our most familiar examples suggested. We may have been studying our own family photo and calling it a census. There is a household feeling hidden inside that cosmic idea. Imagine growing up thinking every kitchen smells like yours. Same bread, same soap, same stove heat, same soup on the back burner. Then one day, a sealed lunchbox drifts in from another city, and when you open it, the smell tells you whole neighborhoods live differently.
That is what 3I/Atlas gave us. Not certainty about everything, certainty that not everything forms the way it formed here. And once you know that, you cannot go back to assuming your local version is the default version. So when NASA says discoveries like this matter, they are not talking about one flashy headline. They are talking about a shift in perspective. A shift from asking, what is this object, to asking, what does this object force us to rethink about where worlds come from? That is the bigger sentence hiding behind the smaller one. The opening image was a snowball older than the fire now warming it. At the start, that sounds impossible. By the end, it sounds almost gentle, a relic from an older galaxy drifting into a younger solar system, giving up its breath as it passes. We did not expect the third known interstellar object to feel this intimate. Not a stranger anymore, but a messenger. Not just debris, but evidence. Not merely crossing space, but crossing time, carrying a frozen accent from an era before our sun had a name. And now the strange part is not that it came here. The strange part is that the universe may be full of stories like this, moving past us all the time, while we sit under one local sky thinking our neighborhood taught us the whole language of worlds. That is the misunderstanding this comet quietly broke. At the beginning, the impossible image was a snowball older than the fire touching it. Now the image has changed. Now I see a traveler moving through the dark, shedding a thin, ghostly breath, while a younger star briefly lights up its oldest memories. The contradiction did not vanish. We learned how to read it. That may be the real lesson hiding underneath the science. We keep expecting the universe to reveal itself in giant explosions and obvious signs. Sometimes it does the opposite. Sometimes the deepest update arrives as a faint blur in a telescope, a few strange ratios in a spectrum, a tiny mismatch in cosmic bookkeeping that tells us our home story is not the only story. And that should make the night feel different. Not emptier, fuller. Not colder in the lonely sense, but colder in the ancient sense, full of preserved things, sealed things, patient things, waiting for warmth and light to say who they are. If a comet can carry that much memory, imagine how much history is still drifting unseen between the stars. Somewhere tonight, beyond the reach of your window, 3I/Atlas keeps going. Colder than any freezer, older than any mountain, dimmer than any porch light. And yet, for a brief moment, it let us read a few lines from a chapter written before Earth began. Carry that with you when you look up. The universe is not only larger than we imagined, it is older in its details and closer in its whispers than we knew.